Oh, I think, okay, cool. All right, it started. Hi, everybody. Today we have a special speaker, Eli. I've worked with him quite a bit on MPSGE and WiNDC. He's very, very, very helpful and useful and good. He's going to talk about WinDC.jl and MPSGE.jl. So I'll let him take it away. Go ahead, Eli.
Cool. Yeah, so my intention is to kind of like show how I use it as a way to show sort of like application, press the buttons, how to sort of use the functions that are built in or like, build functions off the two different packages. I don't know if I'll get through everything I've prepared because, I do quite a bit with it, but, we can jump to anything that anyone's particularly interested in. So here's the sort of basic setup. So I'm using both packages as my primary sort of software to answer this research question about the interactions between carbon dioxide emissions and methane emissions. The specific sort of case here is the US using a static model just to investigate the nuances of the interactions in particular with the least assumptions, so sort of keeping it as a static model. And so with that in mind, I'm going to sort of show how I get the data, specifically using a version of the WiNDC Julia package. The WiNDC Julia package, I'll say as a sort of upfront caveat, is still in development, but totally functional. And as it's in development, we've got a few branches going, and I've got one branch that's not 100% correlated with the current branch, but it will all be sort of similar, if not the same, in terms of like what functions do what. And I'll be explaining kind of what the functions are that I'm using. So even if the syntax isn't exactly the same, the process will be. So I'm going to go over that, sort of highlighting how I'm using it and how it's sort of structured, the basic stuff of it. And then the same thing in terms of the model that I use comes straight off the WiNDC model, the basic model that the WiNDC has, put out years ago, but MPSG Julia version of that. So I'm going to sort of show that, and then I'll show my adaptations from that model that I've used in order to be able to answer this particular question and sort of highlighting the differences. And with one of the things I wanted to do was do a real like hit this button and this is how I start the package sort of thing, as much as we can. Let's see what we have time for. So before I get into the software stuff, I just wanted to give a quick background on the research question for context, which is to say, looking at US emissions, there's a high overlap between carbon dioxide emissions, or I should say between the kinds of activities that are associated with carbon dioxide emissions and the kind of activities that are also associated with methane emissions. So we have this overlap whereby coal mining releases, or coal mining gets coal, ultimately the coal is burnt, and we get carbon dioxide emissions, the main greenhouse gas, and at the same time, coal mining itself causes methane emissions. So the activity of coal mining is associated with both kinds of emissions, meaning that if we're going to affect coal mining in some way, we're going to have some kind of interaction with both carbon dioxide and methane. This is not about the topic, so I won't get into the details about it, but that's the general idea is like, well, what happens if we have policy that we're focusing on carbon emissions, but we're going to have some effect on methane emissions? What would that be? And how is that? What's the sort of character of that interaction? Then I usually present just sort of general context of emissions, sort of relative magnitude. The gray is carbon dioxide emissions in the US, and the yellow is methane. You can see it's sort of proportional, about 10%, and it's kept pretty proportional over time, more or less. And then, we know US emissions are pretty significant. It sort of quantifies that relative to global emissions. So this is US in the area bars filled relative to the lines, which are global emissions. So we're still at pretty much like 10% of global emissions, which is disproportionate of population, obviously. And also to highlight that this combination, this methane carbon interactions are likely significant in most countries. That's the second highest greenhouse gas in globally and pretty commonly, right? All right. So then in my model, I basically start from the WiNDC national model, this sort of generic, what Tom and people call the canonical. So this sort of generic model of the US, snapshot of the US economy on a national scale. So no regions, but like one national economy with 71 sectors coming basically from the BEA summary level. And there's an intermediate demand, intermediate production block, margins, Armington block, which has sort of trade. So we get imports from the rest of the world, exports can, or production can go either to the domestic market or to exports per sector, and then a single representative consumer. And then taxes are represented, all the taxes in the economy are represented by 3 different taxes. Intermediate demands are the production and the import tariffs. So that's the basic model, and I'll show a version of that, but just sort of have a sense of what I'm building from. And then the data and the WiNDC data comes from the BEA, which takes the sort of summary data, the summary level BEA data, which is the 71 sectors more or less. But WiNDC is also able to make use of the more detailed sectoral disaggregation. So BEA publishes 400 so odd sectors and commodities of the same data, same structure. And what the WiNDC package does, or the WiNDC sort of the GAMS thing and then the Julia package replicates, is being able to use that disaggregated detail, align it with the summary so we can get, instead of just the 3 years for the details, it builds the disaggregated for all years. I'll talk briefly about that. So far, so good, more or less. So basically, and you know, really quickly, one of the things the package does, besides take the raw data and structure it for the model and calibrate it, so that it does sort of 3 things. So it structures it for this canonical national model. It calibrates it so that it mathematically balances, where the raw data will have, you know, sort of from the observations doesn't balance. And it also does that thing that I just mentioned, which is to say it takes the detailed level sectors and the data from that and uses that to, in combination with the summary, to get annual detail, in case you might want that, which is actually one of the things that I use in this example. So basically for the 3 years, and I'll just say this, you know, pretty quickly, but I'll jump in if you want to, and maybe Mitch will explain it better. And you'll tell me, Mitch, if I'm saying it wrong. But for the 3 years that the details are already available, obviously you already have the detail. Then for any year before the first detailed year, so 2007 and before, so we have annual data from 1997. So for any year that you might want detailed data from 97 up to 2006, you'll use the sort of relative shares from summary to detail and apply that to any of those years. So the assumption is the relative amount that's split between sort of like the agricultural sector and forestry will be the same in any year. You know, 2007 will be close for any year before that. Obviously, it's going to be most true as you're closer, but there's no other detailed data to build from. So we just use the 2007 data. So it'll say, like, if forestry was 10% of the agricultural summary level data in 2007, it will be 10% in 97 and so forth. The same thing going forward from 2017 until the next detailed year is available. You'll take whatever the 2017 sort of shares were and go forward and use that. And then anything in between, and this is sort of where it gets a bit interesting, is it'll take a weighted share between the 2 sort of bracketing years. So say you're at 2015, it'll sort of weigh more heavily on the 2017, less heavily on the 2012, but actually still use both of those. And these are the sort of way the weights go. So 2 years out, I think you'd get 0.6 weight on the 2017 shares and 0.4 weight on the 2012. Anyway, so I thought that was sort of interesting and did a lot of work to figure that out so I could talk about it. But basically that way we get detailed level data if we want to use it, or as much as we want to use for any possible year between 97 and say 2022, or now if I had updated data, which I don't have running for myself, but we can get 2023. All right, and then I did want to use a combination of, in general, the summary level, which is sort of, the model is set for, plus a bit of extra detail that was appropriate for my question. So I want more detail on the energy sort of relevant sectors and some of the other sectors that are particularly relevant for methane. So before I sort of show you the code and everything, this is the general thing that I had. On the left here, can you see my arrow? Probably not. But anyway, on this sort of left column, oh, good. These are the sectors that would be in the 71 summary level, BEA summary level. And on the right column is the sectors I wanted to end up with. So these top two, I've got the summary level, and what I have here, the utilities. In the detailed level, utilities is already split out into 3 different types of utilities: gas distribution for, gas, burning gas for whatever you want to use it for, water and sewerage, and electric power are all separated already in detail. So for this and for this other sort of separation, which is all non-oil and gas mining, which includes all minerals, but it also includes coal in the summary level, I wanted to split out and separate what is already available with the detailed level, keeping in mind that I'm using 2022, so it's using WiNDC split, the WiNDC disaggregation already. But I'm not doing any custom sort of separation. I'm just using the already WiNDC built-in detailed for those. So instead of using the standard BEA utilities, I'm just taking those 3 as is from the detailed level. So that at this point, I've got sort of like 71, now I've got 72, 73. And then from mining, I'm splitting, which is sort of 7 or so detailed levels, and I'm taking 1, which is coal, and then the other 6, which is like, silver, gold, and whatever other minerals are in there, and keeping those all together and calling them mining. So I've got another one that's 74. So instead of 71, I've got at this point 74. And then there are 2 sectors relevant for this question, or these kinds of questions, that are even in the detailed level data in BEA, and therefore WiNDC detailed. They are still a single sector. So oil and gas, because they're basically mostly a single activity. When you extract oil, you also get gas. You probably, I don't know, maybe everybody knows this, but you can either harvest or, extract and commercialize both the oil and the gas, or you might commercialize sort of just the gas, but there's sort of maybe, I don't know, if there's a little oil, or you maybe just get the oil and then any gas is sort of a waste, or something you just have to manage. But in general, they sort of come together. And so in the BEA data, at least even at the detailed level, they're one sector because the activities are basically overlapping. They don't get details between them. But I want to separate them out, so I've done that as a custom split, and I'll at least get to some of that today to sort of show how do I take the detailed level, single sector, and split it out as a custom split. And the same thing basically coming from that electricity generation. So even at the detail level, I've split it into the 3 utilities, but I want to split renewables out so that I can separate that from the fossil fuel electricity generation, because firms need to choose between the carbon intensity of their electricity in order to respond to the policy. Any questions? So this is what I end up with.
Question: Do you take joint production of joint output from one sector?
Joint output Can you, what do you mean by that? I'm sorry, I might not be missing it. I'm not following the.
So the current version of the GAMS version of the WiNDC actually has features joint output from one production or the sector of production.
You mean like different commodities?
Yeah, different outputs or different commodity being produced from one sector.
Yeah, so the WiNDC national model has, as comes straight from the BEA data, like every sector could produce any and all of the 71 commodities. I think I wasn't familiar with that exact term in this context, but so every sector will primarily produce its own commodity. That's kind of just normal in the data, but could produce any and all of the other 70 sectors. And the same thing happens at the detailed level. So it comes straight from the data. I guess if that's joint production, yeah.
Yeah. Okay. There's only one thing that I've noticed when I try to analyze the data, the base year data. More of the almost all sectors actually they produce over 90% their own commodity. The only thing that stands out is the electricity. So it's about like electricity is reported. I think it's based on the dollar term. 70% probably 70% is coming from power sector, and the rest is coming from service. So I guess that there's like the service sector reporting the transmission distribution of electricity as part of the output.
Okay.
Wondering that there's any of the special treatment of that.
Yeah, no, I haven't. I hadn't thought about that, but I will think more about it. I'm glad you're bringing it up. I've just done a straight split. So what I'm taking here, and I'll sort of show, the numbers, is basically electricity supplies electricity with the fossil fuel intensity based on its inputs. And I do not have service sector electricity in any special, it's not separated out. It's still in the supply chain. So I'll have to think about how that fits if I'm not separating out the electricity supply from the non-electricity sector, how that fits. If they purchase similarly from fossil fuels or from the petroleum sector, the emissions will still flow. I'll show you how the key thing here is how the emissions are connected to extraction level. And so all the emissions will flow with the extraction. So the choices that firms make about their electricity are only coming from that electricity sector, but the emissions, if they purchase from other sectors as well, will still be tracking. So that's interesting to think about. I have to think more about that. Yeah, I'm not even going to get close to everything I have, but I think that's fine. And we can jump ahead if you feel like you're missing something you're particularly interested in. But I just wanted to highlight here, and just really quick, it's got similar sort of information from the previous slide where you can see the 71 sectors plus the sort of elements that I've split out. I've got, the borders, line borders around the ones that are coming straight from the detailed level, and the dotted border around the things I've done custom splits. And the only additional information here is which sectors are relevant for this question around energy and methane emissions. Green is the methane relevant ones. Blue is, as it says up the top, sort of methane and carbon. So that's the sort of focus on this overlap, is the fossil fuel sectors are basically producing both, but other sectors are also producing methane emissions. So they're both going to be in this model. All right, so here's where, see how this goes. So now I was going to try and do a code moment. Mitch is going to have to fight something to stop himself from freaking out about my delightfully messy code here. But what I really wanted to do Okay, so I am going to show VS Code sort of from scratch. So, okay, things to ignore are a bunch of comments. So everything that's green, not everything that's green, but some stuff that's green, try to ignore it. And this is not, the idea is not to show in detail every line of this code. That's not sort of the point. The point here is to say, this is VS Code. This is sort of a little sense of how I'm running stuff. How do I show only active speaker? Okay. So I wanted to show a few VS Code things in case, you know, it helps people get comfortable if they're not. So here on the left, we have all these buttons and they're just sort of, Explorer is just kind of the files. So I've got a few folders open, top level folders. The main one I'm looking at is this is where my model scripts and all my data is in this one here. I also have the MPSG whole repo here that we're not going to really look at that right now. And probably not going to talk about either of these, but I just want to show that you can, you know, look at the directories, whatever files you want just from this one. This is a search function. This is the version control sort of part that you're interested in. And this is testing. And this is sort of my active window. So my active window means what do I have saved into memory right now? And I have nothing. So I just closed down my active sort of running code bit. So I have nothing running, which I wanted to do just to show you sort of from scratch how everything goes, which is to say, I already have Julia installed. I have all of these packages installed. And I won't necessarily go into that, but I just wanted to show at least from the start. So, you know, I found my script. It's called WiNDC data. So aggregation of WiNDC data is sort of how I ended up calling it. I've opened that, got it in. I've got two windows here in VS Code. And then here I'm just got my cursor on here and I'm Shift Enter to start running the script. And the first thing I'm doing when I hit Shift Enter, it's got this using statement, and then VS Code is going to say, oh, using, this is the Julia syntax. So it's going to recognize that it's Julia, and the first thing it's going to do, maybe this is going to be too slow, but it's going to start Julia. So see, I've got this little green thing here that says Julia. That means it's already said, okay, Julia's running, and it's already run. These packages are going to be actively ready. So I still don't have anything. Well, no, I do. So now the Julia REPL, my Julia sort of version is running in here, my packages. So they're just the little brackets or whatever they call these parentheses say, okay, all these are ready to go. Anything from these packages you can run and from Julia base. And then Shift Enter, I just run parts of my code. So I won't go into it all in or much of it in detail at all because I wanted to try to get an overview, but I just did want to be able to show like, no, do not fully test this. What's my move here? Okay. Scramble.
It's saying raw data directories. Do you know where the data is located?
Because I'm not in the right directory. Forgot. Damn it. I spent so long on the presentation, I didn't do a run of this. All right, I'm going to try something. I'm going to show you something else. So this is a different version. Okay, so I'm going to point out a couple of quick things. In this script, which is my actual model of my actual research model, I have this early on in the script, which says include. And I've got this statement here, which says if this variable, which is what I've called the data, the sort of organized data, if it's not already available, then run this script, right? So the include says run, I hope this works. Don't work with animals or live code. don't know if this is going to work. Maybe it will. So what that means is I don't even run the aggregation code independently if I don't want to. I just run my main script and it will call that other script, run it as part of the whole thing. And if it doesn't cause any problems, we'll call it good. So famously, one of the things about Julia is that with any kind of like function, wait, is this right? How am I saying it? So it's much slower the first time because it activates everything. And then once you've got it going the first time, then everything's really fast. But I wanted to sort of take it from go. I think what I should probably do is switch back to the slides a little bit so we don't just sit here watching this little wheel spin. It won't take too long. Maybe I could also, maybe while we're here, just say a couple of things about VS Code or check in about some stuff. Oh, okay, here's one fun one I wanted to show you guys. So shortcuts, which are useful is like that shift enter that I talked about, where that'll run a line and then skip to the next line. So you can sort of just hold shift and enter. Okay, thank goodness the path was already in there if I do it this way. And you can see that I'm already running the aggregation and the calibration routine, and I'm getting some output from that. This has given me the output from the aggregation file, which is basically showing me all the a dictionary of all the different data that I'm using in the model. And so luckily that works. So now if I wanted, should be able to go back here, I think, without having to muck around with the error that I had was that I hadn't said what folder I was in, what directory. But when I ran it from here, it all worked out. The different sort of references to the different paths were in there. So I'll go back here. You know, it just would have taken me a minute to remember where to sort of set my, so now I think, okay, do that. So PWD just says like, where is the code looking at? Like present working directory, or I don't know what P stands for, something working directory. So just saying where is this sort of baseline, anyway, directory stuff. But and then I'll run the code, shift enter if I wanted to do it line by line, and then sort of skip over to the next line as I go. Basically, this whole script takes some of the functions from the WiNDC package and then organizes everything, does all the calibration. So I'll just quickly talk through a couple of those. And then I wanted to quickly show what I've done, a little bit of custom stuff that's pretty messy. And so I wouldn't necessarily say it's at a point that you would want to replicate, but it gives an idea of what we've done, and we'll do it in a sort of better way. But oh, the reason none of this is working is because it's irrelevant. Because I was doing something else. I forgot. So sorry, Mitch. Okay, this is what I actually was meant to run before, and that's why everything worked. So that is where the raw directory is. That code that I just commented is irrelevant. So basically, this function, or this is just saying, you know, where are you supposed to be? That's what I should have done first. And this is taking the raw data and organizing it into the data frame. That's the raw data, national data on the summary, the detailed level and the summary level is this line here. We've picked a year because we have all years available. And then this is the projection step where it takes the appropriate data and gets the 2022 detailed in the way that I talked about on that slide. Right to the instant. Forgot what this does. I'm going to highlight just a couple of things. So here's the calibrate routine. You saw that running before when I ran it from the other script. So it does, what you'd expect. It sort of uses the algorithm IP opt. Is that right, Mitch? IP opt, and does a calibration where we get a balanced data set. And we could check that data set by running the model, just the MPSG model that automatically come out called M. Does that also for the summary level. Pretty quick. And this is a function that says, okay, here's the new calibrated in the second last column and the original, and you could have a look, and these are it's sorted by the biggest differences if you wanted to inspect that. And then I've saved it as a data frame. It's saved as a data frame. No, I'm not going to do that. I was going to say you could look at it, in any detail. Here we're only seeing the very first few and the last few lines. There's 52,000 something odd lines. If we want to look at any particular one, we would say like whatever we want. Is it all? Is this the wrong way? Quick catch it before I do the wrong way. Is it column then row?
It's row column. You probably need an exclamation instead of a.
Yeah. So.
Oh, that one is a colon. The first one is exclamation for all rows. The second one's a colon for all columns.
Yeah. So as a data frame, this is how you would just get one row, or like say we wanted, 20 rows or something, like 21 rows.
Okay.
Just like whatever, Julia, basic data frame stuff. So we could have a look and inspect anything we wanted. Don't speed up, but maybe skip ahead. The thing I wanted to highlight from this script was here. So what I've done, and I talked about this before, so I've taken this gas and oil sector, and I want a gas sector and I want an oil sector. So in order to do that, I looked for data, external data come from EIA, I think, that looks at what is the sort of split in production between sort of value of gas produced and value of oil produced ultimately. And I've used that value to as the sort of coefficient to split that sector for the production relevant parts of the model. And then I've got a split on what is oil exports and gas exports. And I have a value for that, and I use that as a coefficient to split the exports and on the imports, right? And then I've done a similar thing, like what is the relative production of renewable electricity compared to fossil electricity? Renewable here includes nuclear, just because I'm mostly interested in emissions and not the technology. And similar for imports and exports of electricity. What's the split in terms of imports coming from Mexico and Canada? How much of that is renewables? Exports, and it's weighted, and then exports going out from the US. So using these proportions, so you'll see they're all adding up to 1, right? So I've got oil and gas here, two coefficients, which will sum to 1. And we're going to use those numbers with some, I'm not going to get into the code because it's a short presentation, but basically using those values, setting up little data frames that sort of align them with codes in the appropriate way. And then with some data frame manipulation here, I'm applying that to use those shares and splitting it out to end up with the splits that I talked about. So I'm just going to, I'll just run it, but it's not going to show anything particularly interesting, but just to show that once I've figured out all the code, I also say, Mitch had a quick look at the code and he's like, you're doing way more than you need to. And it's probably not the most succinct way of running this code, and I'll work on that. But for me, it works, so it doesn't matter at this point. But I end up with ultimately, after a bunch of mucking around, again, like it's not the most elegant or succinct, but it works. So that's what counts for me. And I end up with, the data as it would be for the WiNDC, but split in the way that I want. Yeah, Shirley.
Oh, thank you for this. I was just curious, kind of in this split, the first two lines that you showed us splitting oil and gas and splitting electricity and renewables. Are those applications for specific regions, or is the subsequent code the code following, like applying it in more detail to regions?
Yeah, the national model that I'm using for this research only has like US and rest of the
Okay,
world.
okay. And so
So
this
the
applies
data,
to both US and rest of world, these splits.
well, the rest of the world is just sort of the region that we would either import from or export to. So there's no the imports is using data on Canada and Mexico, the two places where US imports electricity from, or
Oh, okay, okay. So that's what I
for
guess
the
I heard,
electricity.
Canada and Mexico. Okay, so there is not a
Yeah, that
disaggregated.
just was relevant because we only import electricity from adjacent,
Okay,
contiguous countries. The imports of oil and gas are from rest of the world in general. It's data on all imports. I only mentioned Canada and Mexico because I specifically wanted a weighted. I wanted to weight like how much was renewable from because Canada has a lot of renewables and Mexico
oh,
doesn't, but we get most of our imports from Canada. So I just want because that data was available and it was relevant for the split that I was doing. Whereas for the oil and gas imports and exports, it sort of didn't matter the proportions where they came from or anything because it's just overall oil exports or overall oil and gas imports.
okay. Thank you. Sorry, I missed that part about
No.
Canada and Mexico.
Yeah, that's why the only reason I mentioned it just happened to have that extra data. So basically, then I sort of do all these splits with a bunch of unnecessarily complicated and convoluted functions and data frames, but totally functional. And then I kind of bring it back all together into this one type, which is this sort of national table data frame. And then I've named them. So I did the split first. Then I name it here. I put aggregate, split, then aggregation. This helps me keep track of it. So the name of the data setup that I have has done the split first. Then I've done the aggregation to the sectors, back to the sort of 76, which I end up with. And then I do a calibration on that. Even though I showed you the calibration before, ultimately what I'm using is being calibrated after. All right. So, all right. I'll quickly switch to slides for a couple more quick slides about the WiNDC model. No, wrong one. What have I done? Maybe it's not even worth mucking around with. So we're here. Yeah, it's not that it's presented view, but it doesn't matter. Then I was just gonna, I won't actually get into it, but the production block in the WiNDC model basically looks like this. 71 sectors, we've got other blocks, but I just sort of want to quickly go to this and then I'll show the whole model in my version, which is just a script version, not a function, back in VS Code if I can. Okay, I'm going to switch back again. And show like that production block and the whole national model in the MPSG version. And I have that open right here. And then I've got the shortcut. You do Control KM and it makes only this first window, not the second one. And this is the whole model. So on the packages, activate the packages. Here I've got the data loaded. This is different data. This is not the split one. This is the generic data coming from the WiNDC package that I have organized before into these two big files, or actually Mitch organized them for me a long time ago. So just load those in. And then I run, so these are all my indexes or indices, as you prefer. I could run this as a whole script all at once, but line by line, I'm doing that Shift Enter, loading in all my data in the way that I want it to be accessed with a shorter name, picking the year, 2017, whatever. So here, MPSG model. It's my sort of starter model with that name. Define all the parameters, which is anything I might want to change as a counterfactual. So here in particular, I'm focused on the elasticities and the taxes. These are sets of values, all the taxes for every sector, and these are just individual values, elasticities that are applied to all sectors in the canonical model. Sectors. These are the three blocks that we have, the production block, the Armington block A, and the margin block, which applies the trade and transport margins. And then defining all the commodities, which we'll see in our single consumer. And this is the production block and the syntax that the basic syntax that we have right now in the Julie version relative to the YAMS version. So here I'm using a loop to go through for every sector. There's other syntax we could use as well, but basically saying for each of the 71 sectors, generate a production block. In each of those production blocks, right? So it'll be production block Y, production agriculture. Use this elasticity value for the output, which is a 0. I defined it before. Use this one for the top level inputs, S, which is whatever it is, also 0. These are generic. In my model, I have other values. And then this nest, the value added nest, which will go into the top level input, the S substitution block. I'm going to use this value, elasticity VA, which here was defined as a 1. So Cobb-Douglas for the value added nest. So we're combining labor and capital here, then putting with using a Cobb-Douglas functional form, and it's going into the top level S, and then when it goes in S, it's Leontief, right? With a 0 value automatically generated. And the outputs, so intermediate supply, here it's got the taxes on it. So here we've got the individual sector agriculture, but we're looping within that over all the other sectors, including agriculture. So we're supplying, and this is the joint production. Here we're supplying commodities of any of the 71 different commodities just from agriculture. So that's that inner loop here that is for each the outputs are actually all 71. So we're looping through I here. So I'm not getting into any of my research stuff. It's kind of complicated. And then the inputs, we've got, again, the 71. So you see this I in I here, and the dots, which means we're going to loop through all 71 inputs. So we're in agriculture, we're taking in oil, we're taking in paper, we're taking in whatever, all the different things that in whatever proportions come from the data. It's looping through there. And we're also looping through just the two relevant things in the VA nest, which is labor and capital, compensation and surplus. So it is a loop, but it's only over two things in this one. And then we're combining those two at the top level, ultimately in S, and then VA means like what I said before, the elasticity, the Cobb-Douglas function between labor and capital. So that's what's happening here. And then sort of parallel structure for the margins being applied using 0 for each. Here I'm just using the numbers instead of like a parameter. And then the production Armington block. So that's where we've got the outputs go to either domestic or exports. Inputs either inputs come from either imports or domestic production. This PY that came from here. Sorry, that's the margins. I always get them M for margins with the imports mixed up. And then here the imports. That's the whole thing. So I have a shortcut, Alt-E, which runs this whole script, whichever the script I'm in. And run the whole script, and it'll print out the first time slightly slow. Right. So what do I do in the last couple of minutes to highlight? Well, I got through the custom data. I sort of showed, okay, so this is the MPSGE output. We can see the value in our data frame, but I'll just show that the second time I run it, it's basically instant. I hope that's true. Maybe I'm running Teams, just making it slower. So the second time was 2 seconds. The first time took 10 or whatever it was. And then my outputs here are the whole data frame. There's all the output here. It's a benchmark. So we see, you know, the one values we'd expect from the benchmark for all our prices and activity levels and all our margins. Then we can see they're all very, very small, you know, way down in the decimal places here because it's perfectly balanced. We can also see that it's perfectly balanced if we look at this post-sold residual, which is way smaller than 0, or not 0, like our sort of to the negative e to the negative 6, which is our default sort of path default tolerance. All right, I'm going to switch back to my slides for, let's see, one more little something. What will I highlight in the slides in the last minute? All right, maybe what I'll do is I'll just do a quick, I'll just say what I was going to talk about if we had 2 hours. So what I did in my research model, so I told you about the custom data. So I've done these splits where I've taken basically the summary level, because I'm using the canonical WiNDC model, which has the summary level, but I wanted those extra sectors, and I showed you that. But I've done a few other things, which is restructure that demand block so that I've got energy. We talked about it a little bit before, and I've got energy in this structure instead. So I've pulled out energy, the sectors that are relevant for energy, and I've split those into a nest that has fossil, and for direct energy, this is fossil energy. We want either gas or oil, because we don't really use coal as direct energy at this point in any significant way in the US. Might not be true in other countries. And then here I've split out electricity as a sector, and the inputs to electricity are either the 2 fossil fuels that go into electricity in the main in the US, gas or coal, or renewables. As I said before, it includes anything, you know, including hydro, wind, solar, and nuclear. So I was going to show you that in the MPSGE version, I've got specific elasticity values that I apply here that come from the SAGE model and the E3 model. I won't share the code for that, but that's what I would have done if we had more time. And then I was going to talk about how I sort of have used this structure in terms of the emissions. And I mentioned it before, which is to say, in the model structure I have, I've got emissions associated with this, the direct extraction level inputs. So any coal that you buy as either as consumer or particularly as a producer will have associated with it the intensity of emissions of all coal emissions. So if you buy 10% of coal, you inherit 10% of coal's emissions in the US in that year. And that flows through the whole chain. And that way I can capture the emissions even as it flows through the whole supply chain. And then I tax at that extraction level. Yeah. So
on this, in this production structure, why wouldn't you have fossil and renewable sort of being the ones that feed into energy, a sort of alternative?
Oh, I do. Yeah, this is slightly simplified.
I see.
I do have a nest between these. I don't know why I didn't have that available to just pop on here as a slide, but I have a little nest that is coal and I've done it the opposite. Coal and gas into fossil electricity, and I have oil and gas into fossil energy, and then separated that. So there's a choice between renewables or fossil inputs into electricity, and then below that, the split between coal and gas. Is that what you meant?
Yeah, okay. 'Cause I was just thinking about immediately from energy, you could be from fossil sources or from renewable sources, and then you have different types of, okay.
One thing that I don't have is direct renewable energy represented. I don't think it's super significant at that point. This is mostly for like transport. When we're thinking about, renewable transport is mostly electricity anyway.
Mhm.
We're not sort of like solar powered cars are not a thing right now yet. There's not a lot of direct industrial renewables yet that I know of, in terms of significance in the economy. But at some point later down the track, hopefully we will have a lot of that, and maybe that would be relevant. Okay. Other stuff I really wanted to get to, except that I didn't figure out the timing for it, is I've got this really interesting structure for how I've incorporated the marginal abatement for methane. I don't have time to really talk about it, I don't think. But I've got sort of elements where I've taken the marginal abatement curves from the EPA, and without manipulating that at all, I've implemented that stepped structure in the model by using the sort of complementarity structure of the MPSGE sort of base. So that, let's say, if I can do it succinctly and say, like, basically there's a bunch of potential production activities. Each one is either sort of cheap with a high intensity of methane, or slightly more expensive with a slightly lower intensity of methane. So I've set that up using data. So you can basically say, like, if there's no tax, I'm going to use the cheapest technology, the cheapest combination of labor and capital, but then I'm going to have the highest methane emissions. But as soon as methane is taxed, it's going to change my decision as a firm. I'm going to say, actually, it's cheaper than paying the tax for me to actually spend more money on capital and labor, to invest in some equipment, do more inspections, and reduce my methane intensity of my activity. It's cheaper than paying the tax. And therefore, because of the complementarity structure, that will be the level of abatement that's activated in the model. And the methane intensity will be lower. It's a little convoluted to explain maybe, but that's a basic level. And I think it's a very interesting, and I don't know if anybody else has ever implemented anything like this. So maybe at some point we'll talk about that in detail if there's any interest. So that's how I've got the abatement for methane. And I really like the way that it directly comes from the data and uses complementarity to sort of fit straight in the model without manipulation. I don't sort of attach prices or anything. It comes straight out of the data. So then data changes. It's really easy. I've also implemented nested consumption utility, because Larry Goulder was saying that he felt like and it did make a big difference. So I took the current E3 model, like Mark Hafstead and Larry Goulder's model, and basically got the numbers and got their structure. And I've implemented that in MPSG as we have it right now, the Julia version. We don't have nesting in final demand. You can only have single flat level, but I'm pushing Mitch to do it. And one thing I was hoping to do today was to get everybody to say, like, what a great idea, and put it as a higher priority, because I think it'd be cool. So what I've done instead, and you can do it in GAMS as well, I'm sure you guys probably know, is you generate a production block that sort of takes all the consumption commodities as inputs, and then your output is a single output called like utility or like total consumption, and then that becomes your final demand. So because it's in a production block, we can have all the nesting structure. We end up with a single commodity, and then we just have that commodity in final demand. That also means that to be able to calculate utility, which I have as an output for my research, I also had to sort of generate a specific function attached to that production block to be able to take the data as it was and sort of align it. But I think what I want to do, Mitch, is have nesting in final demand, and then we could have a function in final demand that says utility. Now, what is the utility from this counterfactual? All right, so obviously I'm way out of time. This is my model results, which I'll show you a couple of cool, anyway. All right, thanks for going over a little bit. Would have shown more detail about each of these features and the code of how that was implemented. Then Mitch would have had some sort of coronary issue, seeing the my actual code, which he did look at and gave me some feedback on already. And then I maybe would have gone over some results, but I think sort of highlighting the pieces, I think I feel good about it.
Yeah, that's great. Will you have the slides available so we can look at it later and comment on it?
Yeah, the slides are up on the WiNDC
okay.
website attached for this meeting. They include these slides that I didn't go over up to this one. They're on the slides. One of them on each of these little, so the Phillipson. Do you guys know this? What's it called? Hydroeconomic model. I didn't get to talk about that.
The physical analog of an economy or something?
Yeah. It's got a few different names, which I usually have on my slides, but I forget off the top of my head. I always use that picture because it's just so cool. Stocks and flows. Anyway, that was a tangent. But here I've got some GitHub addresses for the specific scripts because my GitHub repo has like 1 million scripts and 1 million bits of data. So you can also look at the slides and then use this to pull the address. Probably if you download it, you can just copy paste it, or you can look at the repo and pull out what you want. But yeah, so you could even look at the scripts if you want to, if you dare.
Yeah, I popped a link to where we have the slides in the chat as well.
Oh, okay. That's what popped up.
All right. Cool. Thank you, Eli. That's very it's nice to have somebody else talk other than me.
I did talk a lot too.
Somebody who knows what they're doing.
They were very interesting, cool. And even you know, whatever errors you did also are very instructive in terms of just seeing what comes up when you do certain things. So that's all great. No worries at all.
Yeah, that was the moment. Live.
All right. Should I quote Tom and say? Should I quote Tom and say we declare victory?
Is that how he does it? Nice. Oh, Tom.
Interesting.
Yeah.
All right. Cool.
All right. Yeah. Good to see you next time, and reach out and happy to talk about this more anytime
Very nice.
you want.
Thank you.
Very good.
Thanks so much, Sheila. This is great.
Yes. It was great.